Now going to question 16, we always start with the prompt, and the prompt here is telling us to complete the text. And the idea of completing the text, well, that's a predictive question. In other words, they're asking us what would come next. But if you simply summarize the text, one answer will usually match what you're talking about. So let's go ahead and figure that out. A team of biologists investigated the mechanism that allows these plants to accelerate their flowering at high temperatures. They replaced one protein with a similar one from another species that, unlike the one that they were researching, displays no acceleration in flowering with increased temperature. A comparison of the unmodified plants with the altered ones showed no difference in flowering at one temperature, but at a higher temperature, the unmodified plants exhibited accelerated flowering while the altered ones did not, suggesting that, okay, we're talking about flowers that accelerate their flowering when they're at a high temperature. And to do the experiment, they replaced a protein in that flower with another species that doesn't do the acceleration at the higher temperatures. In the altered plants, what they found is that there was no difference at a lower temperature, but at the higher temperature, the unmodified plants still had the accelerated flowering, but the modified ones stopped having that acceleration. So they found out that yes, the gene that they were researching was the one responsible. So let's write that down here. The gene was responsible for the accelerated flowering at higher temperatures, which was what was being studied. So let's go ahead and look at the answer choices now. A says, temperature sensitive accelerated flowering is unique to this plant, but we don't really know if there's some other plant that does the same thing. That wasn't really discussed here. Answer choice B, the plant increases its protein production as the temperatures rise. We don't really know if it's the protein that does it or if it's the presence of the protein that causes the change to happen. So an increase of the protein is not really what's going on. It was more about replacing the protein, as we see right here, with a similar protein, not really how much of the protein there was. So I think we can get rid of B. C, the protein enables the plant to respond to increased temperatures. That's synonymous with what I said. The gene was responsible for the response to the increased temperature. So that one's pretty good. And D, the temperatures of at least 22 are required for it to flower. It wasn't about whether it flowered. It was about an acceleration in flowering with increased temperature. So D is definitely irrelevant. And so the answer for 16 is C.